In this video, we're going to solve 1999 Calculus AB FRQ Question 4. So it says, suppose that the function f has a continuous second derivative for all x and that f of 0 equals 2, f prime of 0 equals negative 3, so it gave us a slope. And f double prime of 0 equals 0, it gave us the point of inflection maybe. We don't know if it changes direction. Let g be a function whose derivative is given by g prime of x equals e to the negative 2x, 3f of x plus 2f prime of x for all x. Write an equation for the line tangent to the graph of f at the point where x equals 0. Okay, so we need a point and we need a slope. The point is given to us, it's 0, 2. The slope is negative 3, because that's also given to us over here. So now we would write y minus 2 equals negative 3, x minus 0. Or you could just say y equals negative 3x plus 2. But I'll stop right there. Part B. Is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0? No, we answered that before when we were reading it. F double prime of 0 cannot tell if POI because not enough info if it changes signs. Okay, part C says, given that g of 0 equals 4, write an equation of a line tangent to the graph of g at the point where x equals 0. Okay, so we have 0, 4. Now we need the slope. So we need g prime of 4. Or g prime of 0, I'm sorry, g prime of 0. So when we do this, we're going to get e to the negative 2 times 0. Parentheses 3f of 0 plus 2f prime of 0 equals, so now we're going to get e to the 0, 3, what's f of 0? That's 2, plus 2, and what's f prime of 0? That was negative 3. Close the parentheses, equals e to the 0, 6 minus 6, which is going to be 0, so we're just going to get 0. So now we're going to get y minus 4 equals 0 times x minus 0, or you could say y equals 4. Okay, part D. It says show that g double prime of x is equal to e to the negative 2x, negative 6f of x, f prime of x plus 2f double prime of x. Does g have a local max at x equals 0? Okay. Justify your answer. So, I'm going to need a hell of a lot more room than that. So, we have g prime of x equals e to the negative 2x, 3f of x, plus 2f prime of x. Okay, so g prime of x is going to equal, and this should be double prime. So g double prime of x, this is going to be negative 2e to the negative 2x, derivative of e to the x is itself, times negative 2x, derivative of that is negative 2 times this thing, 3f of x plus 2f prime of x, and this is a product rule. So let me move this over, plus the derivative of the inside now. What's the derivative of the inside? Well, let's write this down, negative 2e to the x. And now derivative of 3f of x is going to be 3f prime of x plus the derivative of 2f prime of x is 2f double prime of x. Okay, so let's see if we could simplify this a little bit. Equals. So now I could say, let's think about how we could simplify this. If I distribute, I'm going to get negative 6. Well, I don't know if I want to just distribute the negative 2. That might make sense. E to the negative 2x. And now I'm going to get 6, or negative 6, distribute the negative 2. F of x minus, going to get negative 4, and 4f prime of x plus e to the negative 2x plus 3f prime of x plus 2f double prime of x. Now let's see if I could simplify this furthermore. They both have an e to the negative 2x, so I could siphon that out, e to the negative 2x. If I siphon that out, I'm going to get negative 6f to the x. Negative 4, positive 3 is going to give me one of those, but negative. Negative f prime of x. Okay, it's starting to look like it. Plus 2f double prime of x. Okay, I think I just proved it. Let me look. Yep. Okay, yuck, 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 yuck. So now, if I want to find if this is, what was the next part? Does g have a local max? X equals 0. Justify your answer. So let's plug in g double prime and check the second derivative. So g double prime is going to equal e to the 0. Negative 6. F of 0 was 2. Minus f prime of 0, what was that? Negative 3. So minus negative 3 plus 2 times, and what was f of 0? That was 0 also, right? Okay, so now I'm going to get 1 emptying to 0 power, negative 12 plus 3 plus 0. So now I'm going to get negative 9. So this thing is concave down, so it has to be a max, right? So local max at x equals 0 because f double prime of x, or g double prime of x, is less than 0. Okay, and I hope this video helped, and I'll see you guys next time.